looking at power and efficiency. Power is the rate at which work is done or energy is transferred. It's measured in watts or W. 1 watt is the same as 1 joule per second and can be calculated using two formulas. Either power equals work done over time or power equals energy transferred over time. Energy transferred or work done should be in joules and time should be in seconds. Let's try an example question. A motor is used to lift a ball. The motor transfers 45 joules of energy to the gravitational potential energy store of the ball in 2 minutes. What is the power of the motor? Give your answer to one significant figure. First, we need to convert 2 minutes into seconds by timesing by 60. So 2 times 60, which equals 120 seconds. Now we can substitute the values into the equation power equals energy transferred over time, which would look a little like this. 45 divided by 120, which equals 0.375. You need to give your answer to one significant figure, which means it would be 0.4 watts. In an exam, you may be asked to compare the power in two given situations, but you won't be given any values, so you can't do any calculations. For example, 2 students push trolleys with the same mass 100 metres. The first student does it in half the time of the second student. Compare the power. We know both students did the same work as the trolleys have the same mass. However, as one student did it twice as quick, they must have twice the power. Duh! We're now going to look at efficiency of energy transfers. In a previous video, we discussed that energy transfers are not 100% efficient and not all energy is transferred usefully. Some energy is wasted or dissipated. You can calculate the efficiency of a transfer by using one of two equations. Efficiency equals useful output energy transfer over total input energy transfer, or efficiency equals power output over total power input. I know what you're thinking. These equations are basically exactly the same. But if the question uses joules, then it's referring to energy, so use the first one. If the question talks about watts, remember watt is the unit of power, so use the second one. A question that would require you to use these equations would look something like this. A car has a chemical store of 278,000 joules. It transfers 45,000 joules of this to its kinetic energy store. What is the efficiency of the car? As there are joules in the question, we're going to use equation number 1. Efficiency equals useful output energy transfer over total input energy transfer. So let's sub in the numbers. 45,000 divided by 278,000, which equals 0.16. You've then been asked to put this into a percentage, so times by 100. So we get 0.16 times 100, which equals 60. When calculating efficiency, you should never have an answer above 100%. So, to summarise, power is the rate at which work is done or energy is transferred, and it's measured in watts. It can be calculated using two formulas. Either power equals work done over time or power equals energy transferred over time. You can calculate the efficiency of an energy transfer by using the equations efficiency equals useful output energy transfer over total input energy transfer, or efficiency equals useful power output over total power input.